So, third and last one of this installment. It's question number 10 of the first assignment of Science 3400. This was the last question that I was asked to do a solution set for. So a car initially at 44 kilometers an hour. Well, initially means just that, my initial velocity, 44 kilometers per hour. Well, you know what? I'm going to save some grief now and we'll just look at it into meters per second. So 1 kilometer, 1,000 meters, and 1 hour, 3,600 seconds. That is going to give me 12.22 meters per second. I'm going to store that in my little memory location A. What's happening for next? It accelerates to 1,464 meters per minute. Now, fair enough, terminology will be confusing, but meters per minute is a velocity, so this means VF equals 1,464 meters per minute, and that is again, let's reconcile units, 1 minute, 60 seconds. That is going to be equal to 24.40 meters per second. And again, good little science student, we're going to put that into memory location B. Continue reading the question. So it accelerates from 12.22 meters per second to 24.4 meters per second over a time of 23 seconds and maintains this constant speed for 1 minute. Oh, just to add some confusion, so it's a two-part question. So what's this thing going to look like? Let's graph it out. Basically, I'm starting at 12.2, I'm climbing to 24.4, and I'm going to continue on at that speed. How long do I continue on at this speed? So if it's taken 23 seconds to get here, and then I'm going to continue for another 60 seconds from here to here. I don't put 83 seconds down here because that's going to confuse the issue. This is actually two different problems. The first part's what's going on when he accelerates. The second part is over here at the 60-second line. So T2, 60 seconds. So let's look at the first problem, or first part of the problem, number 1. Question is, how many feet did it travel? All right, feet, you know what, I'm in meters. Let's do everything in meters, and we'll convert to feet at the end. So the first part of the question, I'm looking for S. I know a U, a VF, and a T. Do I have an equation for U, VF, and a T? Yes, I do. I can either use let's use the average velocity one. So S equals U plus VF, it's the average, so over 2 times T. That is going to be equal to 12.22 plus 24.4 divided by 2 times 23 seconds. That is going to equal, I get 421.15 repeating meters. Again, lots and lots of decimal places. I'm going to store that in my memory location C. Now we need to figure out, so that's in this section here, he traveled 421 meters. So let's figure out what's happening in part B, or the second part. Notice I figured out some colors. Cool, huh? So I'm still looking for distance. I don't have any acceleration. You know what? I can use the same equation. U plus VF over 2 times T, which is going to be equal to, what's my final velocity up at this point here, is 24.4 plus 24.4 over 2. So this just comes back to our grade 8 equation of my velocity times time. And that's going to equal to 1,464 meters. How do I do that so quickly in my head? Because the actual equation, or the numbers given, were he did 1,464 meters in a minute. So what's the total distance traveled? It's going to be this plus this. We have our 421.15 meters that was traveled on the first leg of the journey during the acceleration. Traveled 1,464 meters in the second minute. We add the two of them up, and we end up getting our 1,885.15 repeating meters, and I'm hoping you can convert that into feet to get our final answer of 6,184.89 feet.